March 14th, 2025. Every telescope on Earth suddenly turned to the same point in space. Not because astronomers planned it, but because something out there started talking. For months, scientists tracked what they thought was just another interstellar object 3/Atlas, a cosmic wanderer passing through our solar system. Routine observation, standard protocol, nothing special, until it changed course. Objects in space don't just change course. Comets follow predictable paths. Asteroids obey Newton's laws, but 3/Atlas, it steered itself, and 3 days ago it sent a signal, not random noise, not natural radiation, a message, mathematical, deliberate, impossible to ignore. Right now, as you're watching this, 3/Atlas is still out there, still approaching, still transmitting. And humanity is listening to something we've wondered about for millennia. We are not alone. This isn't science fiction, this is happening. If this grips you the way it grips scientists worldwide, subscribe and hit that bell, like when you're ready, and tell me where are you right now. As you watch this unfold, let's go. So let's rewind to that moment. March 14th, 2025, 2:47 a.m. Greenwich. Meantime, Dr. Sarah Chen is on her third cup of coffee at the Mauna Kea Observatory in Hawaii. It's a routine night shift. Boring. Actually, she's monitoring deep space objects, comets, asteroids, the usual suspects drifting through the cosmic void. Her job makes sure none of them are on a collision course with Earth. Spoiler, they never are. Then her screen lights up, not with one alert, with 17 simultaneously. Every major telescope network on the planet, from the Very Large Telescope in Chile to the Arecibo replacement in Puerto Rico, to the Square Kilometre Array in South Africa, they all detected the same thing at the exact same microsecond. And here's the thing about space observation that doesn't happen. Ever. Telescopes don't spontaneously sync up like some cosmic flash mob. Doctor. Chen's first thought, equipment malfunction. Her second, someone's hacking the network. Her third thought, the one that made her hand shake as she reached for the phone. This is real. The signal originated from coordinates matching 3/Atlas. The interstellar object, currently 2.4 astronomical units from Earth, that's about 223 million miles, roughly the distance from the Sun to Mars, not close but not comfortably far either. And the signal, it wasn't radio waves, it wasn't electromagnetic radiation in any conventional sense, it was gravitational wave modulation. Think of it like this. You know how dropping a pebble in water creates ripples? This object was creating ripples in the fabric of space-time itself. On purpose, in patterns, within 40 minutes, every space agency on Earth received the same data packet. NASA's Jet Propulsion Laboratory, ESA headquarters in Paris, Roscosmos in Moscow, CNSA in Beijing, ISRO in Bangalore. For the first time in human history, there was no territorial dispute, no classified information protocol, no bureaucratic delay, because everyone understood this wasn't about national security, this was about species security. The preliminary analysis came back in 3 hours. Dr. Marcus Webb from MIT's Kavli Institute later told reporters, and I'm quoting directly here, the signal's complexity was immediately apparent. It wasn't noise, it wasn't cosmic background radiation. It was structured, intentional, mathematically precise, and it repeated every 47 minutes with 0 deviation. 0 deviation. Natural phenomena don't do that. Pulsars rotate, but with slight variations, quasars emit radiation but irregularly. Even atomic clocks, humanity's most precise instruments, drift by nanoseconds. But this signal 47 minutes exactly, every single time. By 9 a.m. Eastern Time. The Pentagon had convened an emergency meeting. By noon, a joint task force of astronomers, physicists, linguists, cryptographers, and yes, even psychologists, assembled at an undisclosed location. The psychologists weren't there to analyse the aliens. They were there to analyse us to predict how humanity would react when the news inevitably leaked. Because here's what they discovered in those first 12 hours of analysis. The signal contained prime numbers. You remember prime numbers from school. Right numbers only divisible by 1 and themselves. 2, 3, 5, 7, 11, 13. They're mathematically fundamental, universal. Any civilization capable of mathematics, regardless of how many fingers or tentacles or whatever they have, would recognise primes. They're like the hello of cosmic mathematics. But 3i/Atlas didn't just send random primes. It sent the first 140 prime numbers in sequence. Then it paused. Then it sent them again. Then it sent something else, the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, where each number is the sum of the two before it. That sequence shows up in seashells, galaxy spirals, flower petals. It's nature's favourite pattern. Then came the breakthrough that turned confusion into certainty. Dr. Yuki Tanaka from Tokyo University's Department of Astrophysics noticed something the automated systems missed. Hidden within the gravitational wave modulation was a secondary pattern. The intensity of each pulse, its strength, corresponded to pi. That's right, pi, 3.14159. The ratio of a circle's circumference to its diameter, the number that governs everything from planetary orbits to the way light bends around black holes. And 3i/Atlas was transmitting it to 32 decimal places. Perfectly. Repeatedly. Now, you might think, okay, smart rock doing math tricks. Maybe it's some weird natural phenomenon we don't understand yet. Except natural phenomena don't arrange information hierarchically. They don't build from simple concepts to complex ones. They don't teach, because that's what this signal was doing. Teaching. The primes established basic counting. The Fibonacci demonstrated pattern recognition. The pi calculation proved geometric understanding. It was following the same pedagogical structure humans use to teach children mathematics. First addition, then multiplication, then more complex operations. This wasn't a beacon. This wasn't a distress call. This was an introduction. Dr. Chen, the astronomer who first received the alert, later described the moment she realized what they were seeing. She said, and this quote still gives me chills, "It felt like walking into a dark room and suddenly realizing someone's been sitting there the whole time, quietly, patiently, waiting for you to notice them. And now they're saying, 'Hi, we see you, we know you're there, let's talk.'" Within 24 hours, the news leaked. Of course it did. You can't have thousands of scientists across dozens of countries all analysing the same data and expect silence. A low-resolution spectrogram appeared on Reddit, then Twitter, then everywhere. The mainstream media picked it up by day 2. CNN ran with breaking unexplained signal from interstellar object. Fox News went with space anomaly, what scientists aren't telling you. The BBC kept it simple, signal received from 3i/Atlas. But here's what the headlines couldn't capture the feeling in the scientific community. Talk to any astronomer who was working that week. They'll tell you about the calls at 3 a.m, the Zoom meetings where people forgot to turn on their cameras because they were still in pyjamas, the peer review process that normally takes months happening in hours, the unspoken understanding that everything, absolutely everything, had just changed. Because for decades, we pointed radio telescopes at the sky through SETI programs, listening for alien civilizations. We've sent golden records on Voyager spacecraft, carrying Earth's greatest hits into the cosmos. We've debated the Fermi paradox of intelligent life is out there. Where is everybody? And now we had our answer. They're here. They've been watching, and they just knocked on the door. But here's the question nobody was ready to ask in those first chaotic days. The question that kept Dr. Chen awake for 72 straight hours. The question that made hardened physicists stare at their data with something between wonder and dread. If 3I/Atlas wanted to announce its presence, why did it wait until now? This object has been in our solar system for months. It passed Jupiter's orbit. It travelled through the asteroid belt. It had countless opportunities to signal us earlier, from farther away, with more time for us to prepare. So why announce itself only when it got this close? What changed? To understand why that question terrifies scientists, we need to go back. Back to before the signal. Back to when 3I/Atlas was just a blip on a telescope. Just another piece of cosmic debris that nobody thought twice about. January 8th, 2025. The Atlas survey system, that's the asteroid terrestrial impact last alert system in Hawaii, detected an anomaly. Now, Atlas finds stuff all the time. It's designed to spot near-Earth objects, potential asteroid threats, things that might ruin your Tuesday by slamming into the planet. Since it went online, it's catalogued over 700 asteroids and 66 comets, just doing its job. But this object, it didn't fit the profile. First red flag its trajectory. Most objects in our solar system orbit the Sun in roughly the same plane like vinyl records stacked on a spindle, all spinning the same direction. It's called the ecliptic plane, left over from when our solar system formed 4.6 billion years ago from a rotating disk of gas and dust. Even asteroids and comets mostly stick to this pattern. 3I/Atlas came in at a 47-degree angle to the ecliptic. Not impossible interstellar objects can enter from any direction, but unusual enough to raise eyebrows. It was moving at 31 kilometers per second relative to the Sun. That's about 69,000 miles per hour. Fast, but not unreasonably so for something coming from beyond our solar system. The astronomer who first logged it, Dr. Robert Werik, ironically, the same guy who discovered Oumuamua back in 2017, ran the standard battery of tests. Spectroscopy to determine composition, photometry to measure brightness variations, astrometry to plot its exact path. Everything seemed mundane. Rocky surface, possibly with ice deposits, estimated size roughly 400 meters long, maybe 40 meters wide. Cigar-shaped, like Oumuamua, which made sense for an interstellar traveller. Elongated objects tumble less and maintain stability better during their million-year journeys between stars. The initial classification I-type asteroid, the I stands for interstellar, the third one we'd ever confirmed, hence the designation 3I. Atlas is just the survey that found it. Paperwork filed, data archived, move on to the next discovery. Except one astronomer didn't move on. Dr. Priya Natarajan from Yale. She specialises in gravitational lensing and dark matter. Not asteroids, happened to see Werik's report during a coffee break. And something bothered her. She couldn't articulate it at first. Just a feeling, a wrongness, like seeing a photograph where the shadows don't match the light source. Everything looks fine until you notice, and then you can't unsee it. She pulled a trajectory data and ran it through her own modelling software. Then she ran it again. Then she called Werik at 11 p.m. and asked, "Did you calculate the hyperbolic excess velocity?" Now, let me explain that term because it's important. When something enters our solar system from interstellar space, it has a specific speed based on where it came from and how the sun's gravity affects it. That's the hyperbolic excess velocity, basically. How fast it's going relative to the sun when gravity isn't pulling on it anymore. For Oumuamua, that number was 26.33 kilometers per second. Very normal for an object arriving from the local stellar neighborhood. For 3I/Atlas 31.2 kilometers per second, Verrick's response. Yeah, it's a bit high, but within the acceptable range for objects coming from... From where exactly? Natarajan interrupted. Because I traced the trajectory backwards, this thing didn't come from any nearby star system. The angle's wrong. The velocity's wrong. If I extrapolate its path for the last 10,000 years, and I did, it doesn't intersect with any stellar system within 50 light years. Silence on the phone. Then Verrick said, So where did it come from? That's the problem, Natarajan replied. Nowhere. Or more accurately, from somewhere we can't identify because its origin point is in the middle of empty interstellar space. No stars, no gas clouds, nothing. Think about that for a second. Imagine someone showing up at your doorstep. You ask where they came from. They point to the middle of the ocean. Not an island, not a boat, just water. Empty water. How'd they get there? Where'd they start? It doesn't add up. But here's where it gets weirder. 2 weeks after discovery, astronomers at the European Southern Observatory in Chile were conducting routine follow-up observations. Standard procedure: watch new objects for several nights, confirm the trajectory, make sure the initial calculations were correct. The lead observer that night, Dr. Friedrich Bachmann, noticed something odd in the photometry data. 3I/Atlas was tumbling, rotating as it travelled, which all asteroids do, but the rotation period was changing. On January 8th, it completed one rotation every 6.7 hours. By January 22nd, every 6.9 hours. Now you might think, so what? Things in space slow down. Right. Wrong. In the vacuum of space. There's no friction. No air resistance. No reason for rotation to change unless something external acts on it. A collision? Maybe. But there's nothing out there to collide with. Outgassing from ice turn into vapour possible, but 3I/Atlas showed zero spectroscopic evidence of volatile compounds. Bachmann published a paper titled Anomalous Rotational Deceleration in Object 3, 1/Atlas. It got 47 citations in the first week. Not because astronomers agreed with his conclusions, most dismissed it as measurement error, but because 47 other research teams independently confirmed the same thing. The object was slowing its rotation. Deliberately. Here's an analogy. Imagine you're an ice skater spinning with your arms pulled in. You spin fast. Extend your arms. You spin slower. Physics 101 conservation of angular momentum. For 3I/Atlas to slow its rotation, it would need to extend something, redistribute its mass, change its shape. Asteroids don't do that. By early February, every major observatory had 3I/Atlas on their observation schedule. The Hubble Space Telescope took high-resolution images. The James Webb Space Telescope analysed its infrared signature. Radio telescopes listened for emissions. Nothing conclusive, but the data kept piling up, and each piece added to the growing sense that this object wasn't following the rules. Dr. Chen from Mauna Kea, the same one who'd later received the signal, attended a conference in Pasadena on February 18th. She sat through 3 days of presentations about 3I/Atlas. Different teams, different methodologies, different instruments. But everyone dancing around the same unspoken question. On the last day, during the closing session, a grad student from Caltech stood up during Quanda. Nervous kid, probably mid-20s, still had that eager believer energy that most astronomers lose after their first decade of staring at data. He raised his hand and asked the question everyone was thinking, but nobody wanted to say out loud. Has anyone considered that it might not be natural? The room went silent, the kind of silence where you can hear the ventilation system humming. The session chair, a distinguished professor from Princeton, cleared his throat and said, "Young man, extraordinary claims require extraordinary evidence." "I know, sir," the student replied. "I'm just wondering, at what point does the evidence become extraordinary enough?" Nobody answered him. The session ended. People filed out, muttering about statistical anomalies and instrumentation calibration. But that night, in hotel bars and late-night video calls, the conversation was different, quieter, more honest. What if this thing wasn't a rock? What if it wasn't a comet? What if, for the first time in human history, we were watching something that came from somewhere else and brought intelligence with it? 3 weeks later, on March 14th, 3 I/Atlas answered that question. But before it spoke, it did something even more impossible. It changed course. March 7th, 2025. 1 week before the signal, Doctor. Elena Volkov is running trajectory predictions at the Russian Academy of Sciences Institute of Applied Astronomy in St. Petersburg. It's tedious work. Plug in the current position, velocity and gravitational influences from the sun and planets. Let the computer calculate where the object will be in a week, a month, a year. She's done this calculation for 3/Atlas maybe 40 times since January. Always the same result, give or take a few thousand kilometers due to solar wind and radiation pressure. The object should pass closest to Mars' orbit on March 28th, then slingshot around the sun and head back out into deep space, never to be seen again. Trajectory confidence 99.7%, basically guaranteed, except this time the numbers don't match. Volkov runs the calculation again. Still wrong. She checks for software bugs. Nothing. She verifies the input data against 3 independent sources, all confirmed. Then she does what any good scientist does when the math doesn't make sense. She calls someone smarter than her, Dr. James Chen. No relation to Sarah Chen, just one of those coincidences. Works at NASA's Jet Propulsion Laboratory in Pasadena. He's a trajectory specialist, the guy who calculated flight paths for Juno, Perseverance, and the Europa Clipper. If anyone can spot an error in orbital mechanics, it's him. Send me everything, he tells Volkov. Position data, velocity vectors, timestamp precision to the millisecond. 6 hours later, Chen calls back. His voice has that particular quality that scientists get when reality has just broken one of its own rules. Quiet. Careful, like he's describing a bomb he's trying not to detonate. Elena, he says, you're not wrong. I ran the numbers through 3 different models. Classical mechanics, relativistic corrections, even threw in radiation pressure from the solar wind. Every calculation says 3 I/Atlas should be 180,000 kilometers from where it actually is. Equipment error, Volkov asks, already knowing the answer. 5 different telescopes across 4 continents have independently confirmed its position. The equipment's fine. It's the object that's not following Newton's laws. Let me put that distance in perspective for you. 180,000 kilometers is nearly half the distance from Earth to the Moon. That's not a rounding error. That's not measurement uncertainty. That's not some tiny gravitational nudge from Jupiter. That's a massive, impossible deviation from where physics says this thing should be. And here's the kicker: it happened gradually. Not all at once. Like a collision or explosion, the deviation accumulated over 6 days, roughly 30,000 kilometers per day. If you plot it on a graph, it's a smooth curve, controlled, deliberate. Within 18 hours, every space agency on Earth had confirmed it. ESA's Operations Center in Darmstadt, JAXA in Tokyo, ISRO in Bangalore, CSA in Montreal. The object was not following a ballistic trajectory. It was maneuvering Doctor. Marcus Webb from MIT, remember him from the signal analysis. He's also an expert in spacecraft propulsion. He ran the numbers and calculated what kind of force would be needed to produce that trajectory change. His findings, published in a rushed preprint paper that got 15,000 downloads in the first day. To alter course by 180,000 kilometers over 6 days. 3 I/Atlas needed to produce approximately 0.003 mx2 of continuous acceleration. That sounds tiny. Right. It is tiny by rocket standards. But here's the thing when you're in space. Even tiny forces add up over time. And sustaining that force continuously for 6 days requires energy. A lot of energy. Webb calculated that for an object massing approximately 5 million tons, the estimated mass of 3/Atlas, based on its size and assumed rocky composition, you'd need the equivalent of 12,000 gigawatts of continuous power. That's roughly 12 times the total electricity generation capacity of the United States for 6 days straight, and with no visible exhaust plume, no heat signature, no expelled propellant. The NASA team held an emergency virtual meeting on March 8th. 43 scientists crammed into a video call, talking over each other, proposing theories, shooting down theories, proposing new theories. Someone suggested outgassing ice sublimating from the surface, creating a rocket effect, except spectroscopic analysis showed no volatiles. No water ice, no carbon dioxide, no methane, just rock and metal. Someone else proposed the Yarkovsky effect when sunlight heats one side of an asteroid, creating a tiny thermal force that can alter orbits over millions of years. Except the Yarkovsky effect produces accelerations measured in 1014 ms2. We're talking 10 million times weaker than what 3I/Atlas was demonstrating. Solar sail, no reflective surface detected. Gravity assist from an unseen body. No gravitational anomalies detected. Measurement error across 5 independent observation networks statistically impossible. Doctor. Lisa Hammond from the UK's Royal Astronomical Society finally said what everyone was thinking but nobody wanted to admit. The only remaining explanation is that this object has an internal propulsion system. And it's using it. Silence on the call. The kind of silence that feels heavy, like the air before a thunderstorm. Then someone, a young astrophysicist from Bangalore whose camera was off, asked in a small voice, Should we try to communicate with it? The thing is, humanity already had protocols for this. We'd spent decades preparing for the possibility of detecting an intelligent signal from space. SETI had response guidelines. The International Academy of Astronautics had a declaration of principles concerning activities following the detection of extraterrestrial intelligence. There were committees, procedures, carefully considered diplomatic frameworks. But all of those protocols assumed we'd detect a signal first, a message, something we could analyse, debate, and craft a response to over weeks or months. Nobody had a protocol for, the thing is already here, it's moving under its own power, and we have no idea what it wants. NASA's administrator made the call, continue observation, maximum resources, but no active signalling, no attempts at communication, not yet. Let's understand what we're dealing with first. For 3 days, astronomers tracked 3I/Atlas with obsessive precision. Every telescope that could point at it did. The object continued its course correction. Small adjustments, each one perfectly calculated to alter its trajectory. It wasn't accelerating randomly. It was navigating. Amateur astronomers started noticing too. You can't point every major telescope at the same spot in the sky without someone asking questions. By March 10th, forums were buzzing. Reddit threads with titles like "Why is everyone looking at 3I/Atlas?" started gaining traction. A high school astronomy club in Nebraska posted a video showing their handmade telescope tracking the object, noting that it seemed to be moving weird. The secret was leaking, but the full truth that this object was demonstrating controlled propulsion, that it was steering itself through our solar system, that humanity might be witnessing the first confirmed artificial interstellar spacecraft, that truth was still locked in classified briefings and encrypted emails between observatory directors. On March 13th, Dr. Sarah Chen drew the night shift at Mauna Kea again. She'd been tracking 3I/Atlas for 5 consecutive nights, watching it perform its impossible maneuvers. She'd stopped trying to explain it with natural phenomena. She'd moved past denial into a strange sort of acceptance. Her notes from that night, later published in her memoir, include this line: "I find myself wondering if it knows we're watching, if it's been watching us, and if so, for how long?" 12 hours later, she got her answer. At 2:47 a.m. on March 14th, 3I/Atlas stopped maneuvering, its trajectory stabilized, and then, for the first time since entering our solar system, it transmitted. The impossible object had stopped moving mysteriously. Now it was ready to talk. Here's something most people don't know about space trajectories or fingerprints. When you watch a spacecraft travel from Earth to Mars, that path isn't random. It's calculated by humans using specific mathematical principles: Hohmann transfer orbits, gravitational assists, delta V budgets. Every course correction, every burn of the thrusters leaves a signature in the data. Engineers can look at a trajectory and tell you not just where something is going, but how efficiently it's getting there, what propulsion system it's using, even which mission control team planned it. Natural objects have signatures too. Comets follow parabolic or hyperbolic trajectories dictated purely by gravity and initial velocity. Asteroids trace elliptical orbits shaped by millions of years of gravitational interactions. These paths are messy, influenced by every planet they pass, every gravitational tug, every tiny force, but they're predictable, chaotic, maybe, but consistent with the laws of physics. 3I/Atlas's trajectory, it had a different signature entirely. Dr. Catherine Zhao is a mathematician at Princeton's Institute for Advanced Study. She doesn't normally work on astronomical problems. Her specialty is number theory, abstract patterns, the kind of pure mathematics that seems disconnected from reality until suddenly it isn't. On March 9th, a colleague forwarded her the trajectory data for 3I/Atlas as a curiosity. "Hey Kat, you're good with patterns. Make sense of this." She almost deleted the email. Almost. But something about the data visualization caught her eye, the way the course corrections clustered. The timing intervals between maneuvers. She opened the full data set. Then she didn't sleep for 3 days. What Zhao discovered would later be called the Princeton analysis, and it would fundamentally change how humanity understood what was travelling through our solar system. She started by stripping away all the astrophysics jargon. Forget about astronomical units and heliocentric coordinates. She reduced the trajectory to pure numbers, position changes over time, velocity vectors, acceleration magnitudes, just the math. And that's when she saw it. The course corrections weren't random. They occurred at specific intervals: 6 hours, 12 hours, 18 hours, 24 hours. Always multiples of 6. That alone was suspicious. Nature doesn't prefer neat multiples. But it got stranger. Each correction altered the trajectory by angles that corresponded to divisions of pi. The first maneuver, 0.523598 radians, that's P6 exactly. The second 0.785398 radians, P4. The third 1.047197 radians, P3. Not approximately these values, exactly these values, to 9 decimal places. Zhao called her colleague at 4 a.m. This isn't navigation, it's a proof. A proof of what? That whoever's controlling this thing understands mathematics at a level comparable to us, maybe beyond us. They're not just getting from point A to point B, they're demonstrating mathematical knowledge through their flight path. It's like flying a plane in the shape of the Pythagorean theorem to prove you understand geometry. She published her findings on Arxif, the physics preprint server, on March 11th. The paper was titled Non-Random Geometric Patterns in the Trajectory of Object 3I/Atlas Evidence for Intelligent Course Correction. Within 6 hours, it had been downloaded 50,000 times. Within 12 hours, 3 independent research teams confirmed her analysis. Dr. James Chen at JPL, the trajectory specialist who'd first confirmed the impossible deviation, took Zhao's work further. He plotted not just the angles of correction, but the sequence of manoeuvres over time. And he found something that made his hand shake as he typed the email to his colleagues. The sequence of corrections, when converted to binary based on their magnitude, large correction equals sign 1, small correction equals sign 0, produced a pattern 10 10 10 10 10 10 10 10, alternating, perfectly alternating, for 18 consecutive manoeuvres. That's not a navigation requirement. That's a signal, a deliberate pattern inserted into the flight path itself, visible only to someone analysing the data mathematically. It was saying, I'm not a rock following gravity. I'm making choices. Deliberate, calculated choices. But Chen found something else. Something that would keep him awake for weeks afterward. He calculated the fuel efficiency of the trajectory. In spacecraft design, there's a concept called delta V, the total change in velocity a craft can achieve with its fuel supply. More delta V means more manoeuvring capability. Human spacecraft are brutally limited by this. The Apollo missions had to plan every manoeuvre down to the second because they had barely enough delta V to get to the moon and back. 3I/Atlas had performed 47 separate course corrections by March 13th. Chen calculated the total delta V expenditure approximately 2.7 kilometers per second. For comparison, the Voyager spacecraft, one of our most efficient probes, had a total delta V budget of about 3 kilometers per s for its entire mission. And Voyager weighed 722 kilograms. 3I/Atlas weighed an estimated 2.5 million tons, 3,000 times heavier. The energy requirements were absurd, beyond anything in our technological capability. Chen ran the numbers 5 times, checking for errors, before he accepted the result whatever propulsion system this object was using. It was at least 1000 times more efficient than our best ion drives. At least. And it showed no signs of running out of fuel. On March 12th, a team at MIT's Department of Aeronautics and Astronautics ran a simulation. They asked a simple question: if we wanted to replicate 3I/Atlas's trajectory using human technology, could we? They modelled it with a nuclear thermal rocket, one of our most powerful theoretical designs, never actually built. The result to match 3I/Atlas's performance. You'd need a spacecraft massing 50,000 tons at launch, most of that being fuel. That's roughly the mass of a Nimitz-class aircraft carrier in space, just to perform manoeuvres that 3I/Atlas was doing apparently effortlessly. The lead researcher, Dr. Paolo Lozano, wrote in his report the technological gap implied by these observations is comparable to showing a steam engine to the engineers who built Stonehenge. We can recognise that it's propulsion, but the underlying principles might as well be magic. But here's the detail that still haunts researchers who worked on this analysis. Dr. Zhao, the mathematician who found the geometric patterns, noticed something else in the trajectory data, something she almost didn't include in her paper because it seemed too strange. Too much like she was seeing patterns that weren't there. The timing of the manoeuvres, when plotted on a graph, produced a curve. Not a smooth curve that would be expected from continuous acceleration, but a stepwise curve, like a staircase. And the height of each step, when measured in units of time, corresponded to the Fibonacci sequence: 1 hour, 1 hour, 2 hours, 3 hours, 5 hours, 8 hours, 13 hours. The same sequence that would later appear in the gravitational wave signal. The same sequence that appears in Nautilus shells, galaxy spirals, and flower petals. Nature's favourite number pattern, but 3I/Atlas was using it deliberately, intentionally, in its flight path, weeks before it sent any other signal. It was like someone leaving breadcrumbs, mathematical breadcrumbs, for anyone smart enough to look. When Dr. Sarah Chen reviewed this analysis on March 13th, one day before the signal, she wrote, in her observation log, "We've been asking if it's intelligent. Wrong question. We should be asking how long has it been trying to tell us it's intelligent? And why did we take so long to notice?" That night, she stayed late at the observatory, not because she was scheduled to, but because she had a feeling, the kind of feeling you get when you know something's about to happen, even if you can't articulate what. At 2:47 a.m., her computer lit up with alerts. 3I/Atlas had stopped leaving breadcrumbs. Now it was speaking in full sentences. The first thing you need to understand about the signal is that it wasn't designed for human ears, or human eyes, or any human sensory organ. Gravitational waves the medium 3I/Atlas chose are ripples in spacetime itself. When two black holes collide 1 billion light-years away, they create gravitational waves that we can barely detect with instruments like LIGO, which cost hundreds of millions of dollars and measure distortions smaller than the width of a proton. These waves pass through everything: planets, stars, you, me. They're essentially invisible unless you're specifically looking for them with incredibly sensitive equipment. So when 3I/Atlas started broadcasting in gravitational waves, it wasn't accidentally choosing a difficult medium. It was choosing the one medium that can't be blocked, can't be jammed, and propagates through space without degradation. Is the universe's most reliable communication channel. But here's what made the scientific community's collective jaw drop: 3I/Atlas wasn't creating gravitational waves the way colliding black holes do through catastrophic cosmic events. It was modulating them, controlling them, creating specific patterns of precision that shouldn't be possible. Dr. Rainer Weiss won the Nobel Prize in 2017 for his work on LIGO and gravitational wave detection. On March 14th, he was pulled out of a retirement dinner in Cambridge to look at the 3I/Atlas data. His response, according to colleagues present, was simply, "That's not possible. Show me the raw data." 3 hours later, he issued a statement. The signal demonstrates controlled manipulation of space-time curvature at a level that implies technology thousands of years beyond our current capabilities. Perhaps millions of years. We're observing something that makes our most advanced physics look like stone tools. The decoding effort began immediately, and I mean immediately within minutes of the first detection. An international team assembled through emergency protocols that had been gathering dust since the 1990s. Cryptographers, mathematicians, linguists, physicists, even musicians and artists. Because nobody knew what kind of thinking would crack this. The initial signal structure was identified by Dr. Sarah Chen herself, still in her office at Mauna Kea, running on adrenaline and cold coffee. She noticed that the gravitational wave amplitude pulsed in discrete units, not continuous variation, but steps. Digital, essentially, binary-like. Strong pulse, weak pulse, weak pulse, strong pulse, weak pulse, strong pulse, strong pulse. She ran it through a prime number filter, the most universal mathematical concept we could think of. And there it was: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. The first 140 prime numbers, transmitted in sequence, then repeated. It took 47 minutes to transmit the complete sequence. Then it started again. Identical. Exactly 47 minutes. That number again, the same interval between the trajectory corrections. Dr. Marcus Webb at MIT received the data at 3:15 a.m. He called his graduate student, Amanda Reeves, who specialized in pattern recognition algorithms. "Amanda, I'm sending you something. Don't tell me what you think it is, and just tell me what you see." Reeves ran the signal through her analysis software, the same kind used to decode DNA sequences and analyze whale songs. 20 minutes later, she called back, "Professor, this is either the most elaborate hoax in history, or we're looking at a structured language. There are repeating patterns, hierarchical organization, and what looks like syntax. It's not random. It's not natural. Someone, something, constructed this." The Fibonacci sequence came next. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Each number represented by a specific number of pulses. Then the sequence reversed 144, 89, 55, 34, 21, 13, 8, 5, 3, 2, 1, 1. Forward and backward, like saying, I know this pattern and I can manipulate it in both directions. But the breakthrough, the moment when everyone realized this was genuine communication and not just mathematical showing off, came from an unlikely source. Dr. Yuki Tanaka, the astrophysicist from Tokyo University who'd identified pi in the original signal, was working with a colleague from the linguistics department, Dr. Kenji Watanabe. Watanabe didn't know much about gravitational waves or astrophysics, but he knew how languages work, how they build from simple to complex, how they establish context before introducing new concepts. "It's teaching us," Watanabe said, staring at the decoded sequences. "Look at the structure. Primes establish counting one-to-one correspondence. Fibonacci establishes pattern recognition, predicting what comes next. Pi establishes geometric understanding, the relationship between circumference and diameter. Each concept builds on the previous one. This is pedagogy. This is how you teach someone who doesn't speak your language." And then came the part that changed everything, embedded within the gravitational wave modulation. In the variance of the wave frequency itself was a secondary layer of information. Doctor. Tanaka discovered it almost by accident, running a Fourier analysis to check for interference patterns. The frequency modulation, when converted to numerical values, produced coordinates, galactic coordinates, not random points in space, specific locations. The first set of coordinates pointed to Proxima Centauri, the nearest star system to Earth, 4.24 light-years away. The second pointed to Barnard's star, 5.96 light-years away. The third to Wolf 359, 7.86 light-years away. 12 stars in total, all within 20 light-years of Earth, all in different directions. And next to each coordinate set was a number, a timestamp. Researchers realized not a date, but duration, expressed in units that took hours to decode but eventually revealed themselves as Earth years. Proxima Centauri 6,800 years, Barnard's star 9,200 years, Wolf 359, 12,400 years. Doctor. Chen sat back in her chair when she saw the analysis. "It's not telling us where it's from," she said quietly. "It's telling us everywhere it's been. And how long ago?" The implication hit like a freight train. This object had visited 12 star systems within 20 light-years of Earth. The timestamp suggested it had been travelling for over 12,000 years. And now it was here, at our doorstep. But the message wasn't finished. The final section of the signal, discovered by a team at Arecibo's successor facility in Puerto Rico, was the most complex. The gravitational wave pattern shifted to a three-dimensional encoding amplitude, frequency, and phase, all carrying separate information streams. When decoded and visualized, they produced an image, not a photograph, not a picture of an alien face or a star map, something more fundamental. Hydrogen atom, one proton, one electron, the simplest, most abundant element in the universe, rendered in precise mathematical detail, showing the electron's probability cloud, the energy levels, even the hyperfine structure details that require quantum mechanical understanding to depict. Underneath it, Another sequenced the exact frequency of the hydrogen line emission 1420.405751 MHz, the most famous frequency in astronomy, the cosmic dial tone that SETI has been listening to for decades. Dr. Jill Tarter, former director of SETI Research, was brought into the analysis on day 2. She'd spent 40 years listening for signals from space and found nothing. Now, presented with an actual signal, her reaction was captured in a video call that later went viral. They're showing us hydrogen because they know we know hydrogen. They're using the hydrogen frequency because they know we've been listening at that frequency. They're not just saying we're intelligent. They're saying we know you're intelligent. We know you've been looking. We see you. The decoding effort continued for days. Every 12 hours, new layers of the signal were uncovered. Mathematical proofs of the Pythagorean theorem. The base 10 numerical system, somehow they knew we use base 10. The atomic number sequence 1, 2, 3, 4. Up to 118 every element in the periodic table. But one element was highlighted, marked differently in the signal. Given extra emphasis. Element 6. Carbon, the building block of life as we know it. And the signal seemed to be asking a question, encoded in pure mathematics. Do you understand? Do you recognize this? Are you like us? On March 16th, 72 hours after the first signal, Dr. Sarah Chen stood before a hastily assembled international committee via video conference. Representatives from every space agency, heads of state, UN officials, all asking the same question: should we respond? Chen looked at the camera and said something that would define humanity's next steps. I think the question isn't whether we should respond. I think the signal is designed to make us realize we already have. Every radio telescope we've pointed at the sky, every space probe we've launched, every electromagnetic emission from our civilization leaking into space at the speed of light for the past century. 3i/Atlas didn't come here blind. It knew exactly what it would find. March 17th, 2025. 3 days after the first signal, Dr. James Chen runs the trajectory calculation for the 100th time, hoping the numbers will somehow be different. They aren't. 3i/Atlas is 2.1 astronomical units from Earth. That's roughly 195 million miles, about twice the distance from Earth to the Sun. Sounds far, right, in cosmic terms. It's nothing. It's your next-door neighbour. It's someone standing in your driveway. And it's getting closer. Chen updates the projection model with the latest positional data. The object is no longer making those elaborate geometric manoeuvres. No more mathematical demonstrations. Its course has stabilized into something much more direct. Much more purposeful. The new trajectory brings it to its closest approach to Earth on April 23rd. 37 days away. Distance at closest approach 0.7 astronomical units. About 65 million miles. That's closer than Venus ever gets to Earth. Closer than Mars at its nearest. Not collision course closed, nobody's talking about impact scenarios or evacuation plans, but close enough that you could see it with a decent amateur telescope. Close enough that it will be visible to the naked eye as a bright, moving star. Close enough that whatever's controlling it could observe Earth in extraordinary detail. Dr. Lisa Hammond at the Royal Astronomical Society runs the visibility calculations. Starting around April 15th, it'll be magnitude 3 inches, she tells the Emergency Astronomy Council over video chat. That's about as bright as the stars in Orion's belt. By April 20th, magnitude 1 as bright as Arcturus. At closest approach, magnitude -1, brighter than any star in the sky except Sirius. You won't need a telescope. You won't even need to know where to look. It'll be obvious. Someone on the call asked the question everyone's thinking, can we hide that from the public? The silence that follows is answer enough. You can't hide a bright object moving across the night sky. Amateur astronomers worldwide are already tracking it. The cat's not just out of the bag, it's climbing the curtains and knocking over lamps. But here's what's keeping astronomers awake. The trajectory isn't just bringing 3 I/Atlas close to Earth, it's bringing it to a very specific point in space. Doctor. Elena Volkov at the Russian Academy of Sciences notices it first. She's plotting the object's path relative to Earth's orbital plane when she sees the alignment. On April 23rd at 1437 UTC, 3 I/Atlas will be positioned directly along the line between Earth and the Sun. Not quite an eclipse, it's too far away and too small for that. But geometrically, perfectly aligned. From 3 I/Atlas's perspective, Earth will transit across the Sun's disk, just like we watch Mercury or Venus occasionally cross in front of the Sun. Anything on 3 I/Atlas will see Earth as a tiny black dot silhouetted against the solar photosphere. It's positioning itself to observe us, Volkov tells her colleagues. This isn't a flyby. It's not passing through. It's parking itself in the observation deck. The Chinese National Space Administration runs their own analysis. They calculate the viewing angle, the optical resolution that would be possible from that distance. What could be observed with technology even remotely comparable to our best satellites? Their report, shared with international partners, is sobering from 0.7 AU, with optical systems comparable to our Hubble Space Telescope. An observer could resolve objects on Earth's surface down to approximately 50 meters. Cities would be clearly visible, large buildings distinguishable, nighttime light pollution obvious, weather patterns, ocean currents, vegetation zones all observable in detail. And if their optical technology is as far beyond ours as their propulsion system, they could probably read the license plates on your car. Dr. Marcus Webb at MIT takes the analysis further. He's not just interested in what 3 I/Atlas can see. He wants to know how long it's been watching. He traces the object's trajectory backwards, accounting for the course corrections, the arrival angle, the velocity profile. The results are published in a Rush Review paper on March 19th. Based on trajectory analysis and hyperbolic excess velocity, 3 I/Atlas entered our solar system approximately 8 months ago, crossing the heliopause, the boundary where the Sun's influence ends in July 2024. 8 months. It's been in our neighbourhood for 8 months. Where was it during those months? Webb plots the trajectory. It passed within 0.3 AU of Jupiter in September 2024, close enough to get an excellent view of the gas giant and its moons. It crossed the asteroid belt in November, and from December through February it was lingering, moving slowly, almost loitering in space, maintaining a position roughly 3.5 AU from the Sun. It was observing. Webb writes in his analysis, before it announced its presence, before it started signalling, it spent 3 months watching us, learning about our system, perhaps waiting for the right moment. The NASA team calculates fuel requirements for this kind of mission profile. The numbers are staggering. To travel from the nearest star system, decelerate upon arrival, perform months of observation, and then execute precision maneuvers through the inner solar system. The energy budget would exceed the total power output of human civilization for several centuries. And 3 I/Atlas shows no signs of slowing down or running out of power. On March 20th, the European Space Agency convenes an emergency meeting with their counterparts from NASA, Roscosmos, CNSA, JAXA, and ISRO. The agenda has 1-item response options. The proposals range from ambitious to desperate. Option 1, do nothing. Continue observation. Wait to see what 3 I/Atlas does at closest approach. Risk we look passive, unprepared, or uninterested. Option 2, active communication. Respond to the signal with our own mathematical message. Show that we understood their transmission. Risk we might say the wrong thing. we might invite interaction we're not ready for. Option 3. Send a probe. We have one spacecraft that could potentially reach 3I/Atlas before April 23rd if we repurpose an orbital satellite, strip it down for speed, and launch within the week. It wouldn't be sophisticated, just a camera and a transmitter, but it would be something. Risk it might be seen as aggressive, or worse. It might reveal just how primitive our technology really is. The meeting lasts 7 hours. No consensus is reached. Every option feels simultaneously too cautious and too reckless. But while governments debate, someone else makes a decision. March 22nd. The Arecibo Successor facility in Puerto Rico receives an unauthorized access alert at 3:47 a.m. Someone has taken control of the radio telescope, overriding the safety protocols, pointing it directly at 3I/Atlas. Security traces the intrusion to Dr. Sarah Chen's credentials. But Chen is asleep in Hawaii, her laptop untouched. Someone used her access codes that were supposed to be secure, codes that were supposed to be classified. The telescope transmits for 17 seconds before automated systems shut it down. 17 seconds of a radio signal broadcast at maximum power, directed at the coordinates of 3I/Atlas. The signal's content, the Arecibo message. The same message we sent toward the globular cluster M13 in 1974. A simple binary transmission showing human figures, our DNA structure, the solar system, the atomic numbers of key elements, a greeting card from Earth, except this time, the recipient is close enough to actually receive it. The signal will reach 3I/Atlas in approximately 17 minutes at the speed of light. NASA issues a frantic statement. The transmission was unauthorized and does not represent the position of any space agency or government. But it's too late. The message is already traveling through space at 186,282 miles per second, closing the gap between humanity and whatever intelligence controls 3Y/Atlas. Chen is woken by a phone call at 4:15 a.m. Hawaii time. Sarah, someone used your codes to contact the object. We need you to come in immediately. I didn't, she starts to say, then stops. Wait, did you trace where the breach originated? Yes, the security officer replies. Your credentials were used from an IP address registered to CERN, the particle physics facility in Geneva. That's impossible. I've never even been to CERN. I don't know anyone there who would... She stops mid-sentence. Her blood runs cold, because she remembers something from the decoded signal, something buried in the third layer of the transmission, something the team found on March 18th but couldn't explain a string of numbers that corresponded to geographical coordinates. The coordinates for CERN, somehow, in its message to Earth, 3I/Atlas had included the exact location of one of our most advanced scientific facilities. A facility that houses the Large Hadron Collider, the most powerful particle accelerator ever built. A machine that, for brief moments, recreates conditions that existed fractions of a second after the Big Bang. And now someone or something at that facility had just responded to 3I/Atlas using stolen credentials. Doctor. Chen sits on the edge of her bed, phone pressed to her ear, and asks the question that nobody wants to answer. What if it's already here? What if whatever's on 3I/Atlas? What if it's already on Earth? The security officer doesn't respond, because 2 hours earlier, at 1:47 a.m. Geneva time, CERN security systems detected an anomaly. One of the underground access tunnels sealed for maintenance registered movement. Motion sensors activated. Cameras showed nothing. But the magnetic field monitors, the instruments designed to detect the tiniest fluctuations in electromagnetic fields, they recorded something impossible. A field distortion moving through the tunnel at walking pace, purposeful, controlled, heading directly toward the control room where the unauthorized transmission originated. By the time security arrived, The tunnel was empty, but on one of the sealed doors, someone or something had left a mark. Not scratched, not painted, burned into the metal itself, as if by concentrated heat or radiation, a symbol, mathematical, precise. The hydrogen atom diagram from the signal, and underneath it, 3 numbers 37, 23, 14, April 23rd, 2:37 p.m, 2014. No, wait. April 23rd at 14:37, the exact date and time of closest approach. 36 days away. 3I/Atlas wasn't just approaching, it was counting down. Let's take a breath. Let's step back from the countdown clocks and the burnt symbols and the unauthorized transmissions. Let's talk about what we actually know. Not speculation, not fear, just the confirmed, peer-reviewed, independently verified facts about 3I/Atlas. Because in all the chaos of March 2025, one thing became crystal clear: we were no longer dealing with uncertainty. We were dealing with something terrifyingly real. Fact 1, it's not natural by March 24th. 17 independent research teams across 12 countries had published analyses confirming the same conclusion. No known natural process can explain 3I/Atlas's behaviour. Not outgassing, not radiation pressure, not gravitational assists, not measurement error, Doctor. Alan Stern, the principal investigator of NASA's New Horizons mission. The spacecraft that flew past Pluto put it bluntly in a press conference. I've spent 30 years studying objects in our solar system. Asteroids, comets, Kuiper Belt objects. They all follow predictable physics. 3I/Atlas doesn't. It violates no laws of physics, but it demonstrates engineering. That's not an opinion, that's an observational fact. The object's density is wrong. Spectroscopic analysis shows a rocky, metallic surface, mostly iron and silicates, similar to M-type asteroids. But when you calculate the mass based on its gravitational influence on passing space dust and micrometeoroids, the numbers don't match. It's too light, about 40% less dense than it should be if it was solid rock and metal. That means it's hollow, at least partially, and hollow space rocks don't occur naturally. Fact 2, it has a power source. On March 21st, the James Webb Space Telescope detected a thermal anomaly. 3I/Atlas's surface temperature is approximately minus 150 degrees Celsius cold, but expected for an object that far from the Sun. But there's a hot spot, a region on what appears to be the aft section, measuring roughly 40 meters across. That's 73 degrees warmer than the surrounding surface. Dr. Martin Rees, the UK's Astronomer Royal, ran the thermodynamic calculations. For a passive object, something just absorbing and radiating sunlight, this temperature differential is impossible. The heat distribution should be uniform within a few degrees. This hotspot requires an internal energy source generating approximately 2.4 megawatts continuously. 2.4 megawatts. That's enough to power about 2,000 average American homes. Continuously. For 8 months so far, with no sign of stopping, what kind of power plant could run for 8 months without refueling? Our nuclear submarines can manage about 3 months before needing to return to port. Our space probes carry radioisotope thermoelectric generators that last decades, but they produce only hundreds of watts, not megawatts. 3I/Atlas is operating on a completely different level. Fact 3. It's communicating in multiple frequencies. The gravitational wave transmission gets all the headlines, but it's not the only signal. On March 18th, radio telescopes at the Very Large Array in New Mexico detected a faint radio emission at, you guessed it, 1,420.405751 megahertz, the hydrogen line frequency, the same one encoded in the gravitational wave message. But here's what's strange. The radio signal is incredibly weak, almost too weak to detect. Doctor. Jill Tarter's team calculated that if 3I/Atlas were transmitting at the same power level as our most powerful radar installations, we wouldn't be able to detect it at all from 2 AU away. which means either it's transmitting at much lower power than we would, or it's deliberately keeping the radio signal subtle. Why use gravitational waves for the main message and radio waves for what air whisper? A side-channel doctor. Amanda Reeves at MIT proposed a theory that's gained traction. Maybe the gravitational wave signal is the public broadcast, the announcement. But the radio signal that might be a private channel, a handshake protocol, something meant only for those who are actively listening at the right frequency. SETI facilities have been listening at 1,420 MHz for decades. If you wanted to contact someone who was looking for you, that's exactly where you'd call. Fact 4, it knows things it shouldn't. This is the part that keeps scientists up at night. The CERN coordinates in the signal, the timing references that correspond to Earth days and years, the use of base 10 mathematics, the counting system humans use, not a universal standard. We use base 10 because we have 10 fingers. An alien civilization could just as easily use base 8 or base 12 or base 16, but 3I/Atlas uses base 10. Dr. Kenji Watanabe, the linguist from Tokyo, compiled a list of everything 3I/Atlas seems to know about Earth. Our mathematical conventions, our primary astronomical observation frequencies, the location of CERN 46.2 degrees, N 6.1 degrees. Our calendar system referencing April 23rd, specifically the hydrogen line frequency SETI, monitors the atomic structure notation we use. It's like, Watanabe explained in a video conference, meeting someone who not only speaks your language but knows your local dialect, your slang, even the inside jokes from your hometown. They haven't just studied humanity, they've been watching us closely for years, or maybe longer. Fact 5. We have no defense. Nobody wants to say this out loud in official briefings, but it's obvious to anyone who looks at the data if 3I/Atlas has hostile intent. There's absolutely nothing we can do about it. The US Space Force ran simulations on March 23rd. Could we intercept it? Could we deflect it if necessary? The answer? Classified but leaked within 48 hours. No. Our fastest spacecraft, the Parker Solar Probe, reached speeds of 430,000 miles per hour. Impressive. But it achieved that by falling toward the sun and using gravitational assists. 3I/Atlas maintained speeds comparable to that, while maneuvering freely in any direction. Our missiles can't reach it. Our rockets can't catch it. Our kinetic impactors, the technology we'd use to deflect an asteroid, would take months to reach it, and it could simply move out of the way. Colonel Sarah Martinez from the Space Force put it diplomatically in a congressional briefing. Our current space assets are designed for satellite defense and tracking near-Earth objects. We have no capability to intercept or engage a maneuvering target at interplanetary distances. If engagement were necessary, which we stress is purely hypothetical, we would require technologies we do not possess. Translation: we're helpless. Fact 6. The scenarios all require assumptions we can't verify. Here's where it gets philosophical. Every scenario, analysis, peaceful contact, scientific observation, resource extraction, colonization, whatever requires us to assume we understand the motivations of something we can't even imagine. Dr. Lisa Hammond assembled a think tank at Oxford on March 25th. Biologists, psychologists, anthropologists, philosophers. Their assignment: predict possible intentions based on observed behaviour. The report, delivered 72 hours later, was 200 pages long. The conclusion: 2 paragraphs. We have insufficient data to predict intentions with any confidence. Human history shows that contact between civilizations with large technological disparities typically ends poorly for the less advanced civilization. However, Applying human historical patterns to a non-human intelligence is methodologically unsound. We simply do not know. Recommendation: prepare for all scenarios simultaneously. Hope for the best. Prepare for the worst. Acknowledge we cannot reliably distinguish between the two until events unfold. In other words, we have no idea, and maybe that's the most terrifying fact of all, because sitting in all those emergency meetings, looking at all that data, one thing became abundantly clear: 3I/Atlas holds every card. It chose when to reveal itself. It chose how to communicate. It's choosing when to arrive and where. We're not participants in this first contact. We're observers, or maybe subjects. Something is happening to humanity, not with humanity. On March 26th, Dr. Sarah Chen was cleared of any involvement in the CERN transmission. The investigation continued, but security footage from Geneva showed no human entering or leaving the facility during the relevant time frame. The burned symbol remained unexplained. That night, Chen did something she hadn't done since college. She went to a church. She's not religious, her words, but she sat in the empty pews of a small chapel near the observatory and just sat, processing, thinking. A reporter found her there later, somehow they always do, and asked, "Doctor, Chen, after everything you've seen, everything you know about 3I/Atlas, are you afraid?" Chen was quiet for a long moment. Then she said, "I'm not afraid of what it is. I'm afraid of what it knows. It knows we're fragile. It knows we're divided. It knows we're barely capable of leaving our own planet. And it came here anyway. So the question isn't what it wants. The question is, what does something that advanced want with something as primitive as us?" The reporter asked a follow-up, but Chen was done talking. She was staring at her phone, at a new email that had just arrived from an unknown sender. Subject line April 23rd. The message body contained one sentence in plain text. "We've been waiting a long time to meet you," and attached a photograph. Time-stamped March 26th, 2025, 9:47 p.m. A photograph of Earth, taken from space, from exactly 2.0 astronomical units away. The perspective 3I/Atlas would have, right now. March 28th, 2025. The world is watching the sky, and humanity, for maybe the first time in history, is collectively remembering. Because this isn't the first time we've looked up and wondered. It's not even the first time we've convinced ourselves something impossible was happening. The difference, this time, it's real. Let me take you back. Way back. 1938, The War of the Worlds, broadcast October 30th. Halloween Eve, Orson Welles sits in a radio studio in New York and performs H.G. Welles' science fiction story as a live news broadcast, Martian cylinders landing in Grover's Mill, New Jersey, heat rays destroying the countryside, panic in the streets, except there was no panic in the streets. Not really. That's the myth. What actually happened is more interesting and more relevant to where we are now. About 2% of listeners, roughly 1.2 million people, believed it was real. Not because they were stupid, but because the broadcast was convincing, the format was familiar, and the idea of life on Mars was genuinely scientifically plausible in 1938. We didn't know Mars was a frozen desert yet. We didn't have rovers there or orbiters photographing the surface. But here's what actually happened. Most people who believed it was real didn't panic. They called police stations. They called newspapers. They looked for more information. They tried to verify. The human response to potential alien contact wasn't hysteria. It was curiosity and caution. Doctor. Cynthia Weber, a political scientist at the University of Sussex, has studied the War of the Worlds response extensively. On March 28th, she published an op-ed in the New York Times. Orwell's broadcast taught us that most people, faced with extraordinary claims, seek verification. The mass panic was exaggerated by newspapers who wanted to discredit radio as a news medium. The real story, humans are more rational than we give ourselves credit for. And right now, in 2025, we're seeing that play out again. 1947, Roswell and the birth of modern UFO culture, July 1947. Something crashes on a ranch near Roswell, New Mexico. The Army Air Forces initially reports recovering a flying disc. Then, within 24 hours, changes the story it was a weather balloon. For decades, conspiracy theories flourished. What did they really find? Was it a craft? Were there bodies? What's the government hiding? Then, in 1994, the Air Force declassified the truth it was Project Mogul, a classified program using high-altitude balloons to detect Soviet nuclear tests. Not aliens, not a weather balloon. Something in between, something so secret that the cover story had to be mundane. Dr. Richard Dolan, the historian who specialises in Cold War secrecy, points out the parallel with Roswell. The government chose a cover story because the truth was classified but mundane. With 3 I/Atlas, we're in the opposite situation. The truth is extraordinary, but there's no cover story that would be believable, so we're stuck with transparency by necessity. And that transparency is unprecedented. Every major space agency is publishing data daily. Academic papers are appearing on ArcServe hours after observations are made. Press conferences happen every 48 hours. Why? Because unlike 1947, we can't control the narrative. There are too many independent observers, too many amateur astronomers, too many people with telescopes in their backyards who can see 3 I/Atlas with their own eyes. The secret can't be kept because there are a million witnesses. 1977, the WOW signal, August 15th, 1977. The Big Ear radio telescope at Ohio State University detects a strong narrowband radio signal from the constellation Sagittarius. It lasts 72 seconds. Dr. Jerry Amon reviews the data printout and writes "WOW" in the margin. The signal never repeats. For 48 years, we've debated what it was. Natural phenomenon, satellite interference, actual alien transmission. We'll probably never know, but here's what happened in the aftermath: nothing. The world didn't change. There was no panic. SETI continued its work. Life went on, because one unexplained signal, however intriguing, wasn't enough to transform human civilization. Dr. Jill Tarter, who spent 4 decades searching for signals like WOW, reflected on this during a CNN interview on March 29th. The WOW signal taught us that we wanted proof. We wanted repeatability. We wanted something undeniable. Well, now we have it. And I think we're discovering that we weren't as ready as we thought we were. Because 3 I/Atlas isn't a maybe, is not a single unexplained blip. It's continuous. Repeating, approaching, undeniable. 2017 Oumuamua and the question we should have asked. October 2017. Astronomers detect the first confirmed interstellar object passing through our solar system. It's elongated, tumbling, and slightly accelerating as it leaves, suggesting outgassing. Maybe, or something else. Harvard astrophysicist Avi Loeb suggests, cautiously, that it might be artificial, a light sail, perhaps technology. The scientific community reacts with, let's call it skepticism. Loeb is criticised for speculation, for jumping to conclusions, for not following Occam's razor, 8 years later. On March 30th, 2025, Loeb publishes an essay titled "We Should Have Looked Harder." In it, he writes, "Oumuamua was our warning shot. An object with anomalous properties, behaving in ways that stretched our models. We explained it away because we preferred natural explanations, because we weren't ready to consider alternatives. But what if our preference for mundane explanations caused us to miss the obvious? What if Oumuamua was a scouter probe, and we let it pass without serious investigation because we were afraid of seeming foolish? It's a haunting thought. What if we've already been visited before and we just didn't notice science fiction versus reality, the contact paradox? Here's something fascinating humanity has been imagining alien contact for over a century. H. G. Wells, Arthur C. Clarke, Carl Sagan, arrival, contact, expanse. We've written thousands of scenarios, explored countless possibilities. And yet, when it actually happens, none of our fiction prepared us. In the movies, aliens arrive in obvious ways. Giant ships hovering over cities, transmissions in English, clear intentions, usually invasion, occasionally peace, always cinematic. Contact happens in the third act, and by the end of the film we understand what they want. But 3i/Atlas. It's been here for 8 months and we still don't know why. It sent a mathematical greeting and then nothing more. It's approaching Earth but not threatening, demonstrating intelligence but not explaining itself. It's prolonging the ambiguity, and that ambiguity is driving us crazy. Doctor. Ted Chiang, the science fiction author who wrote Story of Your Life, which became the film Arrival, was interviewed by NPR on March 31st. His observation was striking. In Arrival, the aliens arrive and immediately begin teaching us their language. Communication starts within days. But that's fiction. In reality, 3i/Atlas is showing us that first contact might not be about communication at all. It might be about observation, assessment, patience. The aliens in my story needed something from humans, so they engaged with us. But what if they don't need anything? What if we're just interesting to them? What then? That question, what then, is keeping philosophers up at night. The social media factor, a new variable. Here's something no previous generation had to deal with: instant, global, unfiltered communication. By April 1st, #3iAtlas is trending worldwide. Every platform, Twitter, Instagram, TikTok, Reddit, is flooded with content. Memes, mostly. Jokes about alien tourists. Conspiracy theories ranging from plausible to absurd. Amateur videos of people filming the night sky. Fake leaked documents. AI-generated images claiming to show the object up close. But something else is happening too. Something unprecedented. A shared experience. 7 billion people looking at the same sky, wondering the same questions, feeling the same mixture of excitement and dread. Previous generations experienced world-changing events through newspapers. Radio, television mediated, filtered, delayed. We're experiencing this in real time, together. Commenting and reacting and processing collectively. Doctor. Dana Boyd, yes, lowercase. That's how she spells it. A social media researcher at Microsoft published a rapid response study on April 2nd. Social media is creating a global conversation that's simultaneously unifying and fragmenting. We're all watching 3i/Atlas, but we're interpreting it through millions of different cultural, religious, and philosophical frameworks. The result is unprecedented consensus that something significant is happening, but complete disagreement on what it means. In Jakarta, people are praying. In Mumbai, celebrating. In New York, protesting, though what they're protesting isn't entirely clear. In Tokyo, preparing. In Sao Paulo, partying. In Lagos, debating. In Sydney, watching. Everyone's doing something. Nobody's doing nothing. And that might be the most important difference between now and every previous moment in human history. When Orson Welles broadcast War of the Worlds, most people weren't listening. When Roswell happened, it was a local story for days. When the WOW signal was detected, most people never heard about it. When Oumuamua passed through, it was a curiosity for astronomy enthusiasts. But 3i/Atlas, the whole world is watching. On April 3rd, Dr. Sarah Chen received another email. Same unknown sender, subject line, "You're asking the right questions," message body. 1938, they imagined invasion. 1947, they feared invasion. 1977, they hoped for contact. 2017, they missed us. 2025, they're ready. Chen forwarded it to NASA security. They traced the IP address to a server farm in Iceland. Dead end. Whoever was sending these messages knew how to hide. But the message itself kept echoing in her mind. They're ready. Not, you're ready. They're ready. Who's they, humanity, or something else? 20 days until closest approach. 20 days to find out if everything we learn from history means anything at all. April 5th, 2025, Dr. Sarah Chen stands in front of the United Nations General Assembly. Not physically, she's video conferencing from Hawaii, because leaving the observatory right now feels impossible. But her face is on the giant screen, and every seat is filled. Every member state sent representatives, even the ones who haven't agreed on anything in decades. She's not there to present data. Plenty of people have done that already. She's there to answer one question, posed by the Secretary General himself. Dr. Chen, in your expert opinion, what does this mean for humanity? She takes a breath. And then she says something that will be quoted for generations. It means we were never alone. It means the universe was watching. And it means everything, absolutely everything about how we see ourselves, our place in the cosmos, our future as a species. That all changes today. Let's talk about what that actually means. Not in abstract philosophical terms, but in concrete, practical, life-altering ways. The philosophical earthquake. For thousands of years, humans have asked, are we alone? Every religion, every philosophy, every culture has grappled with this question. Most concluded we weren't gods, spirits, angels, demons, ancestors watching from the sky. But modern science pushed back. Show us evidence. Show us proof. And we never found it. SETI listened for decades. Silence. Space probes explored the solar system. Nothing. Exoplanet discoveries numbered in the thousands. But no signals, no visitors. No confirmation. Until now. Dr. Michael Shermer, a science historian and longtime skeptic of UFO claims, published an essay on April 6th titled The Death of Cosmic Loneliness. In it, he writes, for 400 years since Copernicus, science has been systematically demoting humanity from the centre of everything. Earth isn't the centre of the universe. The sun is just one star among billions. Our galaxy is one of trillions. We accepted our cosmic insignificance intellectually, but emotionally we still felt special, unique, the only consciousness in an unconscious universe. That feeling dies today. We are not special. We are not unique. We are one of how many thousands, millions, we have no idea. But we're definitely not alone. Religious leaders worldwide are scrambling to respond. Pope Francis, in an emergency address from Vatican City on April 7th, says the existence of intelligent life beyond Earth does not contradict faith. If God created the vastness of the universe, why would we assume he stopped with only us? This is not a crisis of faith. This is an expansion of wonder. The Dalai Lama, reached by journalists in Dharamsala, offers a simpler response. Of course there are others. The universe is infinite. Consciousness is infinite. This confirms what Buddhism has taught for millennia. But not everyone is handling it so calmly. Evangelical churches in the United States see attendance spike by 40% in the first week of April. Some preachers call it the end times. Others call it a test of faith. Few, and this surprises people, call it an opportunity. Reverend Marcus Cole from a megachurch in Houston says in his Sunday sermon, maybe God didn't just make us in his image, maybe he made many in his image. Maybe we're about to meet our brothers and sisters from another world. Meanwhile, atheist communities are having their own reckoning. The American Humanist Association releases a statement. The existence of extraterrestrial intelligence doesn't change our values or our ethics. we're still responsible for each other, for our planet, for our future. If anything, this makes our commitment to reason and evidence more important than ever. The technology gap. How far behind are we? Let's get brutally honest here. The technology demonstrated by 3/Atlas gravitational wave manipulation, sustained multi-megawatt power generation in a compact form, propulsion systems with specific impulse thousands of times better than ours, this represents a technological gap that's hard to even quantify. Dr. Michio Kaku, theoretical physicist and futurist, appears on every news network during the first week of April. His message is consistent. On the Kardashev scale, a measure of a civilization's technological advancement based on energy use. Humanity is about 0.7. We use a fraction of our planet's energy. A Type 1 civilization uses all their planet's energy. Type 2 uses their star's energy. Type 3 uses their galaxy's energy. He pauses in one interview on CBS Evening News and adds 3/Atlas. Based on what we're observing, they're at least Type 1.5, maybe approaching Type 2. The gap between us and them is like the gap between a stone axe and a nuclear reactor. We're not in the same technological century. We're not even in the same technological millennium. That's sobering. But here's what's really keeping scientists and military strategists up at night. If the technology gap is that large, then everything we think we know about security, defense, sovereignty, power, it's all obsolete, Doctor. Elena Volkov put it bluntly in a closed-door briefing with Russian officials, which was immediately leaked. If they wanted our resources, they'd take them. If they wanted our planet, we couldn't stop them. The only reason we still have agency is because they're choosing to give it to us. We exist at their discretion. The Pentagon runs scenarios. The Chinese military runs scenarios. NATO runs scenarios. The results are all the same in any conflict scenario. Humanity loses. Completely. Immediately. But here's the strange thing that realization is bringing humanity together in ways nothing else ever has. The geopolitical shift borders becoming meaningless April 8th, 2025. Something extraordinary happens at the United Nations. The Security Council, the 5 permanent members who rarely agree on anything, unanimously passes. Resolution 2847, the establishment of the Unified Earth Contact Initiative. Not just a resolution, a framework, a commitment. All space agencies will share data on 3/Atlas completely and immediately. No classified information, no national security exemptions, everything public, everything transparent. All military space assets will be placed under temporary international coordination. Not control, nobody's giving up sovereignty, but coordination. So we don't look like a fractured, primitive species incapable of working together. All responses to 3/Atlas will be made collectively, representing Earth, not individual nations. The vote is 15-0. No abstentions. China and the United States, who haven't agreed on anything substantial in years, both vote yes. Russia and the UK, France and whoever currently holds the rotating seats. Everyone. Because facing something from beyond Earth, national borders suddenly feel arbitrary, silly, even Dr. Naif al-Rodin, a philosopher and geopolitical expert writes in Foreign Affairs. For the first time since the nation-state system emerged, we're confronting a challenge that makes nationality irrelevant. 3/Atlas doesn't care about our borders, our flags, our historical grievances. It sees one species on one planet, and maybe that perspective, seeing ourselves as one species, is the real gift here. But not everyone's happy about it. Nationalist movements worldwide see this as a threat. Don't surrender our sovereignty to unelected global bureaucrats becomes a rallying cry in several countries. Protests erupt in Paris, Washington, Moscow, Beijing. People who spent years fighting globalization see this as the ultimate globalist conspiracy. The conspiracy theories are creative. Some claim 3I/Atlas is a hoax created by governments to justify a new world order. Others claim it's real, but it's working with specific governments, a popular theory on certain corners of the internet. 3I/Atlas is actually a Chinese or American spacecraft designed to look alien so they can unite the world under their control. The evidence against these theories is overwhelming thousands of independent observations. Multiple countries with conflicting interests all confirming the same data. But evidence doesn't always matter when people are scared. The economic chaos markets don't know what to do. Wall Street opens on April 9th, and it's absolute chaos. Some sectors crash. Airlines see a 30% drop. Why fly when we might be making contact with beings who can cross interstellar space tourism companies Blue Origin? Virgin Galactic see their stock collapse. Who wants to go to the edge of space when something came from beyond it? Other sectors skyrocket. Defense contractors are up 45%. Telecommunications companies surge. Any company with space or technology in its name sees speculative investment. But the strangest thing, overall market volatility is lower than expected. The Dow drops 8% in the first 2 days, then stabilizes. The global economy doesn't collapse. People still go to work. Grocery stores stay stocked. Infrastructure keeps running. Dr. Esther Duflo, Nobel laureate in economics, explains it on Bloomberg. Markets hate uncertainty, but they also adapt. Right now, we're in uncertain times. Yes, but 3I/Atlas isn't attacking, is not disrupting supply chains, is not causing immediate economic damage. So markets are pricing in uncertainty but not catastrophe. It's fascinating. Humanity's economic systems are proving more resilient than we expected. Though she adds, ask me again on April 24, or if something happens at closest approach, all bets are off. The individual response. How people are actually handling this. Here's what surprised everyone. Most people are okay. Not thrilled, not unconcerned. But okay, suicide rates haven't spiked. Crime hasn't exploded. Society hasn't collapsed. People are still going to work, picking their kids up from school, watching Netflix, arguing about sports. Dr. Steven Pinker, cognitive psychologist at Harvard, notes, humans are remarkably adaptable. We normalize the extraordinary faster than we think. 100 years ago, flying across the Atlantic was miraculous. Now it's boring. We'll do the same with this. In 6 months, there will be 3I/Atlas memes. In a year, people will complain that alien contact hasn't immediately given us warp drives and teleporters. But there are changes, subtle ones. Church attendance is up. Volunteering is up. Charitable donations are up 23% in the first week of April. People are calling old friends, reconciling with a strange family. A phenomenon psychologists are calling cosmic perspective taking when faced with something vast and unknown. Humans suddenly remember what actually matters, and weirdly, wonderfully, people are being kinder. Road rage incidents are down. Customer service complaints are down. It's like everyone collectively decided if we're about to meet aliens, let's at least not be arseholes to each other. On April 11th, a video goes viral. A high school student in Ohio films herself and her dad watching the night sky. They're looking for 3I/Atlas, it's visible now. A bright star moving slowly against the background, and the girl says, so quietly the microphone barely catches it, Dad, what if they're just like us, just looking up their sky, wondering if anyone's out there? And they found us. Her dad doesn't answer for a long moment. Then maybe we should make a good first impression. That video gets 200 million views in 48 hours. Because maybe that's the real implication. Not the philosophy or the technology or the geopolitics. Maybe the real implication is this. We're being watched. We're being evaluated. We're being given a chance to show what kind of species we are. And for the first time in human history, the whole world is wondering the same thing. Will we be worth meeting 12 days until closest approach? 12 days to decide. April 12th, 2025. 11 days to closest approach. Doctor. Sarah Chen hasn't slept more than 3 hours a night in 2 weeks. She's not alone. Across the globe, in observatories and space agencies, control rooms and universities, thousands of scientists are running on caffeine, adrenaline, and the gnawing knowledge that they're living through the most significant moment in human history. And they can't do anything but watch. 3I/Atlas is now 1.2 astronomical units from Earth, about 111 million miles. Still far, but close enough that amateur telescopes can resolve it as more than just a point of light. It's elongated, rotating slowly, and that hotspot on the aft section, it's still glowing in infrared, steady as a heartbeat. The object hasn't sent any new transmissions since March 14th. No follow-up messages, no responses to the unauthorized CERN broadcast or the dozens of other signals that various governments, organizations, and even individuals have aimed at it since. Just silence and approach. The global vigil, every telescope on Earth is pointed at 3I/Atlas. Not just the professional ones, amateurs too. Right now, as you're hearing this, there are telescope feeds streaming live on YouTube, on Twitch, on every platform imaginable. Millions of people watching a bright dot move infinitesimally slowly across the starfield is the most watched event in human history, more than the moon landing, more than any World Cup final, more than any Olympic opening ceremony. People have set up watch parties. They're projecting telescope feeds on building walls in cities worldwide. Times Square, Shibuya Crossing, Piccadilly Circus, all showing the same image, 3I/Atlas approaching. The International Astronomical Union established a 24/7 monitoring protocol. Every hour, a different observatory files a report. Position, velocity, spectroscopy, radio emissions, infrared signature, gravitational effects. All data uploaded immediately to a public database. Why public, Doctor? Chen explained it during a press conference on April 13th. Because this doesn't belong to scientists, this doesn't belong to governments, this belongs to humanity. Everyone deserves to see what's happening as it happens. No secrets, no classifications, just truth. And the truth, for now, is that 3I/Atlas is simply continuing its approach. Steady, predictable, following the trajectory calculated weeks ago. But is predictable comforting, or is it more unsettling when something this advanced does exactly what you expect? It means they want you to expect it. They're controlling the narrative, managing the encounter. We're not having first contact. We're being granted first contact. The preparation protocols on April 14th, 9 days out. NASA activates what they're calling the Contact Readiness Framework. It sounds official, it sounds prepared, but everyone involved knows it's mostly improvisation dressed up with acronyms. The framework has 3 phases. Phase 1 observation only. Continue tracking. No active signalling unless 3I/Atlas initiates communication. This is where we are now. Phase 2 responsive communication. If 3I/Atlas signals again, respond through the International Committee using pre-approved mathematical messages. Show we understand, show we're coherent, show we're trying. Phase 3. This is where the document gets vague. Adaptive response based on scenario development. Translation. We'll figure it out when it happens because we have no idea what to prepare for. Doctor. Marcus Webb at MIT was asked during a radio interview, are we ready for Phase 3? His answer, no, but nobody could be. You can't prepare for the unknown. You can only prepare to be flexible when the unknown arrives. No, the European Space Agency has a tracking station in Australia running continuous observations. The lead astronomer there, Dr. Patricia Okoye, noticed something on April 15th that sent ripples through the scientific community. 3 I/Atlas's rotation slowed again. When first observed in January, it rotated once every 6.7 hours. By March, every 6.9 hours. Now every 7.1 hours, still slowing, still changing, and the really weird part, the rotation is slowing in discrete steps. Not gradually, every few days, it drops by exactly 0.1 hours. Precise, deliberate, like someone's adjusting a dial. It's still communicating. Dr. Okoye told her team, not with transmissions, with behaviour. It's showing us it has control. Fine control, it's not drifting, it's not malfunctioning. Every single thing it does is intentional. The public countdown. Someone created a website, Days Until 3 I/Atlas. Just a countdown timer, simple, clean. The numbers ticking down. It's the most visited website on Earth. Billions of hits per day. People check it compulsively, as if the numbers might change. As if April 23rd might somehow arrive early or late. Social media is a strange mix of anticipation and anxiety. The memes continue alien tourists taking selfies with Earth. ET phone home jokes, photoshopped images of 3 I/Atlas with googly eyes, humour as a coping mechanism. But there are serious posts too. People sharing what they hope to tell their grandchildren about this moment. People writing letters to potential alien visitors, thousands of them. Uploaded to a collaborative website. A digital message in a bottle, just in case anyone's listening. A 12-year-old girl in Kenya writes, "Dear visitors from far away, welcome to Earth. We're not perfect, but we're trying. Please be patient with us." An elderly man in Japan writes, "I'm 94 years old. I never thought I'd see this day. Thank you for letting me witness it before I go." A teacher in Brazil writes, "To whoever's out there, I teach children about the universe. Can you help me show them how big and wonderful it really is?" Reading these messages, you realise people aren't afraid. Not really. They're hopeful, curious, maybe a little nervous, like before a first date. We're about to meet someone new, and we want to make a good impression. The scientific scenarios behind the public optimism. Scientists are modelling every possibility. Scenario: a flyby observation. 3 I/Atlas reaches closest approach, observes Earth in detail, then continues out of the solar system. We confirm alien intelligence exists, but we don't interact beyond that. Probability 40%. Scenario B communication attempt. 3 I/Atlas sends more detailed message at closest approach when the signal delay is minimized. We engage in a basic information exchange. First real contact. Probability 35%. Scenario C probe deployment. 3 I/Atlas releases smaller objects, satellites, probes, something into Earth orbit or even toward the surface. Direct investigation. This is the scenario that makes military strategists nervous. Probability 15%. Scenario D. Nothing. It maintains silence, passes by, and we never understand why it came. This might actually be the most frustrating outcome. Probability 9%. Scenario E. The document lists this as undefined contingencies. Nobody wants to detail what those might be. Probability 1%. Dr. Elena Volkov, in a moment of unusual candour during a late-night video call with colleagues, said, "All our scenarios assume they think like us, assume they value communication, or observation, or interaction. But what if they don't? What if their purpose is so alien, so different from anything we can imagine, that our scenarios are like ants trying to predict why a human is walking across their anthill?" Nobody had a good answer to that. The final week, April 16th, 7 days out, 3I/Atlas is bright enough now that you don't need a telescope. Just go outside after sunset, look toward the constellation Virgo, and you'll see it, brighter than any star except Sirius, and it's moving slowly, but visibly over the course of an hour. Churches, mosques, synagogues, temples all holding services focused on the cosmic moment we're living through. Some preach caution, some preach celebration, most preach unity. The Dalai Lama and Pope Francis issue a joint statement on April 17th, the first joint statement they've ever made. It's brief to our brothers and sisters across Earth. Whatever arrives, we face it together. Let compassion guide us. Let curiosity drive us. Let wisdom protect us. We are one human family, and this moment belongs to all of us. April 18th. 5 days out. Stock markets have stabilised. Governments have stopped issuing daily press releases. There's nothing new to say. The world has settled into a strange calm. The calm before. What nobody knows. Doctor. Sarah Chen receives another email. The mysterious sender. Subject line. Final message before arrival. She almost doesn't open it. Almost. But curiosity wins. It always does. The message body. Doctor. Chen, you've been asking good questions. Here's one more. What if we didn't come to observe you? What if we came because you called us every radio transmission, every space probe, every signal you've sent into space for the past century, we heard them. All of them, you reached out. We're reaching back. April 23rd, 1437 UTC. Be watching, not the sky. The signal. We're not done talking. We're just getting started. No signature, no trace. Just that message. Chen sits in her office, staring at the screen. Then she does something she hasn't done in weeks. She smiles. Because maybe the fear, the anxiety, the unknowing, maybe it's all been beside the point. Maybe humanity spent so long wondering if we're alone that we forgot the real question. What happens when we're not? April 23rd, 2025, 1437 UTC. You're living through it right now. Whether you're listening to this in bed, in your car, at work, wherever you are, you're living through the moment when humanity stops being alone in the universe. Every telescope is pointed at 3I/Atlas. Every space agency is listening. Every government is watching. And in observatories around the world, scientists wait, not with dread, not with fear, with anticipation, because for the first time in human history, we're about to hear what someone else has to say. Someone from out there, someone who crossed the vast emptiness of space to find us. And maybe, just maybe, they have answers to questions we've been asking since the first human looked up at the stars and wondered, "Is anyone there, Doctor?" Chen adjusts her headset. Her computer screen shows the gravitational wave detector readings any second now. The clock reads 143700. The detector spikes. Here we go. Whatever happens next, whatever they say, whatever they want, whatever changes, we face it together. 7 billion humans on one small blue planet, looking up at the sky and finally, getting an answer to the oldest question we've ever asked. We are not alone. We never were. And now we get to find out what that really means. Thank you for joining me on this journey through one of the most profound moments in human history, one that's still unfolding. If this story moved you, if it made you think, if it made you look up at the sky a little differently, then subscribe to this channel, hit that bell, share this with someone who loves science, who wonders about the cosmos, who asks the big questions, and tell me, where were you when you listened to this? What are you feeling right now? Drop a comment below. Let's wonder together. Until next time, keep looking up. Because now, more than ever, something might be looking back.